First steps with the Android SDK. With the help of the tools provided by the Android SDK, you may design applications quickly. Using the SDK tools, this chapter will walk you through the steps of creating a straightforward Android application. Topics to be covered. 1. Setting up the development environment. 2. Creating a new project in Eclipse and writing your code. 3. Running the application on the emulator or on a device. 4. Debugging and profiling the application. This chapter will come to a close with a discussion of practical third-party tools. Setup of the programming environment should come first. 1. Setting up the development environment. The Android SDK is adaptable and works well with a variety of development platforms. Purists may decide to use only command-line tools. However, we'll choose the easier, more visual approach by using an IDE, integrated development environment, because we want things to be a little bit more comfortable. The list of programs you must download and install in the specified sequence is as follows. 1. Versions 5 or 6 of the Java Development Kit, JDK. We advise utilizing 6. JDK 7 is currently difficult for Android development as of this writing. The compiler must be instructed to compile for Java. 6. 2. Android Software Development Kit, Android SDK. 3. Eclipse for Java developers, version 3.4 or newer. 4. The Android Development Tools, ADT, plugin for Eclipse. 1.1 Setting up the JDK. Download the JDK for your operating system using one of the versions that are listed. There shouldn't be any difficulties because the JDK comes with an installer or package on the majority of platforms. After the JDK has been installed, you need add a new environment variable named JDK Home that points to the installation's root directory. Additionally, you must modify your PATH environment variable to include the JDK Home, bin, %JDK_Home %bin on Windows directory. 1.2 Setting up the Android SDK. Additionally, the three most popular desktop operating systems have access to the Android SDK. Select the platform-appropriate version and download it. The SDK is delivered as a zip or tar, GZ file. Simply uncompress it and place it in a handy location, for instance, C. Android SDK on Windows or on Linux, opt. Android SDK. The SDK includes a number of command-line tools that are available in the folder for tools. Make an environment variable called Android Home that points to the root directory of your Android device. Add $Android Home, tools, %Android Home %tools on Windows, to the SDK installation your environment's PATH variable. This makes it simple to launch the command-line tools from a should the necessity arise shell later. The core command-line tools required to develop, compile, and deploy Android applications, as well as the SDK Manager, a tool for installing SDK components, and the AVD Manager, in charge of managing Android virtual devices, will be available to you after completing the previous steps. For constructing virtual hardware that the emulator uses, these resources by themselves are insufficient to begin. You must install extra components because they are developing. The SDK Manager is where this comes from. The manager is a package manager, much as the tools for managing packages that are available on Linux. You can install the following categories of components using the manager. Android platforms. There is a platform component for the SDK for each official Android release that contains the runtime libraries, a system image used by the emulator, and any version-specific utilities. SDK add-ons. SDK extensions add-ons are typically external, platform-neutral libraries and utilities. The Google APIs, for instance, which let you include Google Maps into your program, are some examples. Driver for USB on Windows. This driver is required for your application to execute and be debugged on a physical device under Windows. You don't require a specific driver for Linux or Mac OS X samples. There are also a number of platform-specific samples available for each platform. These are excellent resources for learning how to use the Android Runtime Library to accomplish particular objectives. Documentation. This is a local copy of the documentation for the newest Android Framework API 1.3 installing Eclipse. Eclipse is available in a variety of varieties. We advise utilizing Eclipse for Java developers version 3.7.2, codenamed Indigo, for Android developers. Eclipse is distributed in the form of a zip or tar-gzip bundle. Just like the Android SDK, simply extract it to your preferred folder. You can create a shortcut to the Eclipse executable in the root directory of your Eclipse installation on your desktop after the package has been decompressed. Eclipse will ask you to choose a workspace directory when you launch it for the first time. Figure 1-2 displays the dialog for you. 2. Creating a new project in Eclipse and writing your code. We can now construct our first Android project in Eclipse with our development setup complete. ADT's plugin installed a number of wizards that greatly simplify the process of developing new Android projects. 2.1 Creating the project. You must select a few choices once you are in the Android Project Wizard interface. Take these actions. 1. Establish the name of the application. This is the name that appears on the Android launcher. Hello World will be used. 2. State the name of the project. This is the name Eclipse will use to refer to your project. All lowercase characters should be used, therefore we'll type Hello World. 3. State the name of the package. This is the name of the package that will house all of your Java code. The wizard will attempt to guess the name of your package based on the name of your project, but feel free to change it to suit your needs. In this case, Hello World will be used. 4. Indicate the build SDK decide on Android 4.1. As a result, we can use the most recent APIs. 5. List the minimal SDK that is needed. The earliest Android version that your app will support is this. We will select Android 1.5. Cupcake, API Level 3. 6. Press Next. You'll see a box where you can choose the icon for your program. Simply click Next. Everything will remain unchanged. 7. You are asked if you wish to create a blank activity in the following dialog box. By selecting Next, you agree to this decision and continue. 8. You can change some of the attributes of the blank activity that the wizard will build for you in the final dialog. We changed the headline to Hello World, and the activity name to Hello World Activity. Clicking Finish will create your first Android project. 3. Running the application on a device or emulator. We want to run and test the initial iteration of our application code after we've finished writing it in order to find any potential issues or just to be impressed by its beauty. There are two ways we can do this. We can launch the SDK's built-in emulator and test our application there, or we can run it on a real device that is USB connected to the development PC. We can fire up the emulator included in the SDK and test our application there. In both situations, some preliminary work must be completed before we can actually see our program in use. Those are: 1. Connecting a device. 2. Creating an Android virtual device. 3. Installing advanced emulator features. 4. Debugging and profiling an application. Your application may occasionally act erratically or crash. You need to have the ability to debug your application so that you can identify precisely what is wrong. We have access to highly sophisticated debugging tools for Android applications thanks to Eclipse and ADT in our source code. We may set breakpoints, analyze variables, view the current stack trace, and do other things. In order to investigate the state of the program at specific locations in the program, breakpoints are typically placed before debugging. Simply click twice on the gray area in front of the line you want to create the breakpoint at after opening the source file in Eclipse. Do that for line 23 of the Hello World activity class as an example. Every time you click the button after that, the debugger will halt. Double-clicking that line should cause the source code view to display a little circle in front of it, as seen in Figure 2 to 14. Breakpoints may be eliminated by once again clicking them in the source code view. As was mentioned in the previous part, starting the debugging is very similar to running the application. In the Package Explorer pane, right-click the project and choose Debug as Android Application. Similar to starting the program, this produces a new debug configuration for your project. By selecting Debug as Debug Configurations from the context menu, you can modify the default settings of that debug configuration. Useful third-party tools. Adreno Profiler. Used on Qualcomm, Snapdragon devices, HTC primarily, but many others, PVR-Tune, PVR-Trace. Used on PowerVR chips, Samsung, LG, and others, NVIDIA Perf. HUDES. Used on Tegra chips, LG, Samsung, Motorola, and others.